All right, let's do this. So my last chance to remind y'all, the team formation deadline, it is tonight. So if you are intending to be a team, make sure you get that submission in tonight, by tonight. I see a lot of you did submit. The last time I checked, last night, there were still 70 students not on a team. So if you're one of those 70 and you do have your team decided, make sure you get that form submission in, or you will be on a random team. If you're one of those 70 and you want to be on a random team, good job, you're doing the right thing. You'll get an email from me either tonight or tomorrow morning with your team assignment, with your random team that you get. Okay, that's all I want to talk about that. Any questions on that? Oh, and in the other section I did this, so I got to remember to do it here. Just a heads up on what the project is. Team meetings start next week. This is, why team formation is due now. Team meetings start next week. Make sure you're submitting your meeting forms every time you have a meeting. So by the end of next week, I should have a meeting form submission from everybody in the class. Everybody on the team has to submit their own team form submission. Those have to be there. This is the easiest way students find to lose points and sabotage their own grade is by not submitting those forms. Make sure you're submitting them. At the end of each part of the project, when I do individual grade adjustments, I will reduce points if you don't have a form submission for each meeting. Sometimes I give leniency of one, you can miss one and before I start attacking your grade, especially for the first part. But you need those submissions for each meeting, and you need a meeting each week, so a form submission each week. There are some edge cases. If your team failed to meet that week, I've had cases where one team member is trying to reach out and say, guys, we got to meet. We have to do this. And everyone else is just like, whatever, I don't care. Still submit the meeting submission and say, hey, I tried to meet. Nobody else would do it. So make sure you get your submission in there so you're not going to be penalized on my individual grading. Just make sure I get those submissions. Easiest way, I had a student last semester. I don't know what they were ever thinking. I don't know what was going on, but they were part of a team, obviously, and they were a good team member. They were contributing to the project well. Their team overall did really well. The team score on each part of the project was mostly maxed out. They got most of the AOs that they could for the project. But this one team member on that team who was contributing and going to the meetings and everything never submitted the team form submission at all, never submitted the form one single time all semester, so they got almost no credit at all for the project. And I kept leaving them notes like, dude, just fill out your meeting forms. This is so easy. It's a Google form. You can't handle that? Like, what the hell? And still, I don't know if they just didn't read my feedback on Autolab or what, but they lost tons of application objectives just because they didn't fill out those forms. Easiest way to sabotage your grade is not filling those out. So make sure you get those in. And a question that comes up is, when do you have to fill them out? Well, ideally, just fill them out right after your meeting. That's the easiest thing. Then you don't forget. But as long as they're submitted before I do my individual grading for that part of the project, I'm okay with that. I do allow that. So if you forget to fill them out and then you're done with part one, you're like, good job, team. We did it. We made it to the end of this. We got everything. It's working great. And then you say, oh, crap, I didn't fill out any meeting forms. Fill them. You can still fill them out. Just say, this is my submission for week 5. This is my submission for week 6. This is my submission for week 7. Whatever ones you missed. Just get them in before I do individual grading. The timeline for that is the deadline for that part of the project happens. Then the TAs are going to do their grading. They're going to grade the project as a whole. And then after that, I go in and do my individual grading. So there's a few days after the deadline where the TAs are doing their round of grading, up to like a week. And then if you get them in, even during that, I'm pretty lenient on this. I just want your feedback. I really want those form submissions. Those form submissions include what tasks you worked on each week, what you're supposed to do, what you actually did, and your rating for yourself and all of your team members. And I use all that information as to start my process to inform my decisions when I make the individual grade adjustments. So you'll get your team grade, or your team score, and then your individual grade, where I start at your team score and decide if you need extra AOs or fewer AOs than that team score. And I just take all the evidence that I have. And a part of my evidence is You didn't even bother filling out the meeting form. Like, my decision is easy. My favorite ones of these, because it takes me no time to do, is when they're like a team of 4, 2 members filled out all of their meeting forms, and they said, yeah, the other 2 people didn't do anything. Now I don't just flat out take their word for it and start reducing grades. That's not what I do. That's not my policy for this. What I do is look at the evidence and see if I can confirm that they didn't do anything. And if the first thing I see is they didn't even bother filling out the frickin' Google form, the team meeting eval, the meeting report for whatever I call it. I forget. I call it something different every time. But the meeting form, they didn't even bother filling out the meeting form. Easy day for me. They both get zeros. The other 2 members get, whatever the project grade is. If they didn't max out the team score, then I'll probably give them extra AOs because they had to be a team of 2. Not filling out the meeting form is the easiest way for me to say, yeah, they couldn't even do that. I'm sure they didn't contribute to the project meaningfully. Easy decision, easy day. And then I can just move on to the next team and go on to the next decision. So make sure you get those in. Don't be those students. Make sure you get those things in. Too easy of a way to lose points. Okay, anyway. And what the project is. So the meeting next week, that means by Monday, I have to have project part 1 released. That's my deadline for myself. Once the content for something starts, I have to have it out. I also have to have homework 2 released by Monday, so I'll be busy this weekend. But I want to give you a heads up on the project so you can start thinking about what you want to build for your project and what the criteria are going to be. Since I'm not releasing the documents right away, I want to revise them. I can't give too specifics, but here's the overarching what the project is, and it's pretty straightforward. Take the concepts of the course, look at the course schedule, all the stuff that we're going to learn, and stuff it into a project using frameworks. That's what you'll be doing. In the past few semesters, I've had this pretty restricted. Last semester, I had 3 project templates that you would choose from. You choose one of those and pretty much build what I had spec'd out for those ideas. I might still have those 3 templates, but I will at least be adding a 4th, which is open-ended, do whatever the hell you want, as long as you meet these criteria. So you have to incorporate all the aspects of the course. For part 1, that's going to be authentication. That's what we'll be learning the next 2 weeks. Authentication and just generally hosting your app, hosting your HTML, picking what framework and language you're going to use, and all that, all that good stuff. Just setting things up. But auth will be the big first step in part 1. And then parts 2 and 3, we're going to have image uploads and WebSockets. Those are the 2 core features. And then I'll have extra criteria that I'll spell out. Like, you can do whatever you want as long as it has image uploads, WebSockets, and whatever else is going to be included on that list, which will be divided in parts 2 and 3 of what you have to build for each part. So that's a heads up on what to expect for the project. Basically, build a web app using the technologies we're learning, whatever you want it to be. I am going back to open-ended. I haven't had open-ended projects in a while, and I got sick of seeing the same 3 projects, which were my design for every presentation. It got boring, and some students didn't like it either, that they wanted to be more creative, so I want to open that up again. Okay, any questions on all that before we get into content? Let's get into content then. We're talking about APIs today. So we have databases. We talked about databases on Monday. We finally have a database, and we talked about very briefly like how to connect, and we did talk about how to connect, but how to interact with that database in code. And on Wednesday, we said now that we're storing user data and displaying it to all users, we have to be concerned about HTML injection attacks or cross-site scripting attacks. That's our new scary security threat that we have to worry about now that we are storing user-supplied data in our database and hosting it to other users. So the question becomes, how do we let our users interact with our database? This is a big question. Users do have to interact with our database at some level. It's going to be through abstractions, but they do have to be able to get their data in the database. Of course, homework 2, right away, like their chat messages are going in our database. So the user has to get their data into our database. How do we let them do that? And if you say give them direct database access, you are absolutely wrong. Do not do that. That should go without saying, but just to make sure we're all on the same page with that, you could give your user direct database access. And guess what they can do? Like, you're giving them the feature of SQL injection. You're saying you can inject whatever SQL you want, or Mongo, whatever. You can do whatever you want with the database, and the first thing an attacker is going to do is just select star all the stuff. Give me everything. And they have all of your data. Like, you can't do that. They will not have direct database access. So we have to have some layer of abstraction, and today we want to talk about what that layer of abstraction looks like, and it's going to be an API, as the name of the lecture implies. So users are only going to talk to our server, and our server is going to talk to the database. So the user is only interacting, we're building web apps here. The user can only interact with us through web technologies, and so far all we know is HTTP. They're going to connect with a TCP socket and send us HTTP requests, and we're going to send them HTTP responses. So that's their only option. And then our server talking to the database, we can talk about the database operations, and that's exactly where we're going to start. Talking about the database operations. How do we write code? How do we write server code that's going to talk to the database and do the things that we want to do? And I'm going to start with an even more basic question of, what do we want to do? What do we want to do with our data? And here's my answer. We're going to use CRUD operations. This is generally good architecture, the sound architecture of how to interact with your database. Give 4, and we're going to see eventually 5 ways to interact with the data. We can create data, retrieve data, update data, and delete data. These are the 4 operations that we want to perform on our data. And it's good practice to stick with these 4. We don't want to be creating more complex operations that we do. For example, you might be tempted to have one operation or like one method, eventually one HTTP request, once we talk about that side too, that's going to do multiple things. Maybe if I create a record, that's also going to create another record. So maybe I want to, a user creates an account, and I go to the user database, and I create their account for them, and then say, oh, you entered this as your home address. Let me go to my address table and create this record for your address also. We don't want to start doing multiple things or compounding things, or when we update one record, have that create another record. When we update a record and we update a record that references another record, we update this to reference a new record. We don't want to go and like delete this one. We don't want to start having these more complex operations that we make. We stick with these 4, and we can do whatever we want and have more maintainable code, easier to work with our code if we're not getting too complex. So we build these 4 basic operations, and that's all we'll ever need. What more do you want? What more do you want to do with your data than these 4 things? Nothing. That's what. So let's go through these 4. Create, and should be fairly self-explanatory, but there's going to be some new Mongo syntax. Well, if you haven't seen SQL 2, that'll be new too. But insert into with a prepared statement. We talked about that. Insert 1, we talked about this last time as well. We're going to insert a document into a collection or a record into a table. But what I want to talk about is the ID. So on your homework, I forgot to preface this. What we're talking about today is the AOs. This is how we're going to handle the AO stuff. You have everything you need for the LOs. Now that the last thing was security. Bless you. Security. We had all the features before that, but security was the last one. Now we want to handle the AOs. AO1 and AO2, a little bit different. They will take paths that have IDs in them. I'm not going to talk about that too much, but the ID is going to be part of the path that's requested. So being able to parse paths is part of that. That's kind of an implicit thing. It's string manipulation. I'm going to leave that up to y'all to do, is getting the ID out of that string. And then interacting with the record associated with that ID, the chat message associated with that ID, and then also updating and deleting records and modifying your GET requests to be able to get one specific chat message, just building out the rest of this functionality. Because you have to do some of this stuff for LO3, creating a new chat message and retrieving all chat messages, which we'll see is a list operation in a few slides. But I want to add on just a a little bit to create, a little bit to each one of these. So create the IDs. I just said you have to have an ID. For your homework, if you're generating IDs, however you generate them, there's 2 criteria you have to meet just implicitly. One, those IDs have to be unique. I'm not going to be too strict on this. Like if they're not exactly perfectly unique, say you're randomly generating a string that has 10 bits of entropy. So if you're randomly generating like a number between 0 and 1,000,000, there's a 1 in 1,000,000 chance that each record is going to collide with one of the other records. You've taken 250, hash table collisions and all that stuff. There's a probability that you're going to collide, and with that small of a number, you get 1,000 records, there's a pretty good chance you're going to have a collision. It becomes the birthday problem, where you're going to have a high chance of a collision. If it's a high chance of a collision, if the TA notices it during grading, they might give you a 2 and a little warning, but you're not going to lose the objective for that. You're not going to go all the way down to a 1. But they should be reasonably assured to be unique. But that is something out there in the real world. Make sure your IDs are unique. They must be unique. Or else you're going to have ID collisions and just everything goes wrong after that, because the rest of your code is going to be assuming that IDs are unique. So they need to be unique, and 2, they need to be URL safe. So in these IDs are going to be in your URLs. They'll be right in the path, which means they're going to be in the request line of your requests, which means it has to be ASCII only. So if you have crazy characters, non-ASCII characters in your IDs, you either need to percent encode them or just cut it out. Don't do that at all. Don't have crazy characters, crazy non-ASCII stuff, or reserved ASCII characters in there, because it has to be URL safe. So those are the 2 criteria. The URL safe is implicit because it's going to be in the URL, at least for the AOs. I suppose you could get away with that for LOs. I wouldn't be too mad at that. But if you're using SQL, this is easy. You slap auto increment on your ID, and it does all that for you. Everything's going to be fine. It's going to be integers starting at 1, and then just auto increment each record that's created. It's going to add 1, and that's the new ID. So MySQL, problem solved. One of the ways where MySQL is a lot easier than MongoDB. Overall, MongoDB is a lot easier for this class. MongoDB, a little bit tougher. Whatever solution you come up with for this, it's fine, as long as it's URL safe and they're reasonably assured to be unique. I'm fine with that. If you want to try to use the ID that MongoDB generates, keep in mind that that is, 1, it's an object, so you have to do some processing there. And 2, it's underscore ID. The spec is to have ID. The homework says it needs to be ID with no underscore. So make sure you're doing some level of processing to make sure that's stored as ID, not underscore ID. That might sound like a nitpick, but like the front end is designed, it's coded to look for ID. It's got to be ID exactly. That's the spec for the API. My favorite solution, I got sick of fighting this battle, but I used to require auto-incrementing integers, even if you're using MongoDB. And my favorite solution, my intended solution for this, was you have a separate collection that stores the last assigned ID, and then you pull from that collection each time a new record is created. You pull from that collection, add 1, that's your new ID, and then store that +1 integer into the collection. So you have a collection that's just storing 1 single value, and you're using that to remember what the last ID is. And that way, even when you restart the server, your next created record, your next chat message, doesn't start over at ID 1 because your latest ID is stored on disk in the database. So that's the most robust solution. It will just work in all situations. I shouldn't say all. I'm sure it breaks in some point. Somebody in the last lecture mentioned integer overflows. You got to be aware of things like that. If you have billions of records in 32-bit ints, sure, but it's pretty damn robust. Any other solution that students like to come up with usually has a flaw when you delete records. So you can think of your favorite way that you would solve this problem. In the other lectures mentioned, count the number of records that exist and then add 1 to that. That's your next ID. Or you go to the database and find the record with the highest ID and then add 1. That's your next ID. Both of those have the issue of what happens when somebody deletes records. So if I have records with IDs 1, 2, 3, and 4, somebody deletes record with ID 4 and then creates a new record, does it get ID 4? If your code's given ID 4, you got problems and you got bugs because somebody requesting that deleted record, not knowing it was deleted, is just getting a completely different record returned. We don't want that. Okay, and then retrieve or list. List is the one I haven't quite mentioned yet. Yes. Zaid. Yeah, it's unique enough. It's definitely unique enough for our purposes. If you want to use MongoDB's generated ID and make that work in the context of the assignment, just make sure you're not using that underscore and make sure you, it might just be URL safe. I don't think it is though. I think because it gives you an object, but whatever you have to do to process it, if you want to use that, I will consider as unique enough for the assignment. And I would assume they got to be actually unique for that collection, right? Within the collection. Okay, so retrieve. And this is specifically list that I have here. So list is when we want to retrieve every record. That's what, and the LOs, that's what you're doing. You have a get chat messages that just returns absolutely everything. We call that a list operation. Retrieve is when you're just getting one single record. So the acronym is actually CRUDL, but I think that sounds dumb. It's the only reason I don't use CRUDL. It's not the best reason, but hey, that's why I don't say that. That's why I like to say CRUD. CRUD just rolls off the tongue real easy. CRUD-L or CRUDL, I just don't like it. But usually when I say CRUD, I mean CRUD-L. And we have 5 separate operations where 2 of them are both retrieving data, but list retrieving all of it. This is your select star in SQL and your find with no query in MongoDB. And if you want to retrieve a single record in SQL, retrieve star where ID equals whatever ID you're looking up, and then find one in MongoDB and give your query where the ID equals 3. And we talked about that syntax for SQL and MongoDB Monday, so no big surprises here. Then update. We want to update a record. Here's the syntax. I used to just say find the documentation, but the syntax, it's fine. Simple enough to just slap on a slide. So update from this table and set email and username equal to whatever the user gave us. This is user supplied information. So prepared statements, always prepared statements on these things. Where ID equals 5. So this will update every record with ID of 5, which should be unique. You should only be updating one record here. And then set these values to these fields to these values. In MongoDB, this is update 1. What update 1 does is finds one record that matches your query and updates only that one. So if you do have a messed up query, where you accidentally submitted with an empty object here, an empty dictionary, it'll only update one record, so it won't do maximum damage. There's also update many, which will update every record that matches your query. This should only be 1, so we're going to use update 1 because, I don't know, it should have the same effect as update many. Update where ID equals 5, and we're going to use the set command, which is a string, as the field of an object, or a dictionary. I keep wanting to say object because I'm thinking JSON, but since we're in Python, dictionary, as the key to the dictionary, and then the value is another dictionary, which is going to be the keys and values to set. So this will set email and username to whatever I give it. And again, there's no worry about MongoDB injection. We can just put the user data right in this object. And this is the reason why we can get away with that, is because this is handled as a completely separate thing. There's no way, no matter what the user puts here, to be able to get a dictionary with set or any other command in MongoDB. They just can't do that. They can try to type in a dictionary with all that stuff, with some MongoDB thing that does a whole bunch of stuff, but it's just going to be treated as the value for email. And it's going to be treated as a string. It's not going to be parsed. MongoDB is not going to look at this big dictionary, this dictionary here, and say, oh, you want to set email equal to oh, hey, wait a minute. This string looks like a dictionary that has some MongoDB commands. I think I'll treat this as MongoDB commands. No, it's just going to treat it as a value. Just treat it as a string, flat out. So no worry about injections there. That's why, now that we have a bigger example, we can actually talk about why there's no injection attacks. If the client library does start treating strings, like if it lets you give this all as one big string, now you're open to MongoDB injection attacks. That's what some client libraries will do, is start interpreting strings as commands, and that's how you get in trouble. And with update, don't let them update ID. IDs, we do a lot of work to enforce unique IDs. Don't let the user mess that up. Don't let them change the ID. Delete. In the world of SQL, delete from a table, where, and then your query. Delete one in MongoDB, and then a query. So delete the first document it finds with ID equal to 2, or delete many if you want to delete all matching the query. We're deleting by ID, so delete one makes more sense. And this is, I want to make sure I'm clear because I always get questions on this and I cause too much confusion. This is what you should do on your homework. This is fine. You can just do one of these two commands depending on what database you're using. You can just delete it. In the real world, this is not required on your assignment. That was the confusion. People thought that you had to do this on the assignment. You don't have to do this on the assignment. In the real world, this is often how it actually works. If you want to do this on your assignment, I will not stop you, and I will give you a trophy. Well, I can't commit to that. If one of you does this, I'll give you a trophy. If 20 of you do it, I'm not going to spend that much money on trophies. But you should get an award if you do this on the homework. Is actually soft deleting things. So we don't actually delete information out there in the real world. This shouldn't happen in any real app out there. They shouldn't be deleting. There are maybe some edge cases like a VPN that says they never store records. Like they should actually be deleting things, fine. But most cases, in most instances, you shouldn't actually be deleting anything. We want to preserve all of the data. So instead what we do is called a soft delete, which means we mark the record as deleted, and then we stop serving it up. No matter what the queries are, no matter how people are trying to interact with the database, we don't give them that data. We can pull it from the database, but we're never going to send it to anyone. But like admins, anybody with database access, direct database access, can still see everything, even though it was deleted. That's how we like to do things. Few reasons for this. One, for a UX reason, user deletes something. They call up tech support and they're like, opening a ticket and saying, hey, I deleted something. I really didn't mean to delete that. Like, can you retrieve that for me? Can you undelete it or whatever? And if you actually deleted that data, the answer is no. You just say, nope. Then the user's mad, upset, or whatever. But if you soft deleted it, you go, sure. You can go into the database, unmark it as deleted, and done. That's it. That's all you have to do. No other action required. So those accidental deletions, we can handle that. And it's also helpful for debugging. So if you have a bug, say you have a situation where a user creates a record, and then the user on the front end says, I want to delete this record. And now somehow, somewhere in your code, that causes a bug. Somewhere in your code, you're expecting that record to exist. Maybe you have another record that references that record, and that record's deleted. You no longer have that reference. Now you have a situation where you have a bug, but it's harder to debug that because you actually deleted the data. If you actually deleted that, you're losing some of the evidence that you can use to find and fix your bug. But if you soft delete it, it's a lot easier to figure that out. In that example, this record would have a reference to something that doesn't exist. You might still figure that one out. But if the bug is just create a record, delete a record, and now there's a bug, there's no evidence that that record ever existed if you actually deleted it. But if you soft delete it, you can start debugging, look through logs, look through the database. You can find out what actually happened there. So a couple of reasons why we like to soft delete. You can share the trophy. I'm actually going to have to buy a trophy now. But I'm fine with that. I'll stick with it. All right, so that's how we interact with our database. How do users interact with us, or with our server? And this is it. That's how we're going to do it. So we have to map our CRUD operations to HTTP methods, and this is where we're going to, oh, yeah, Zaid, you probably should have a trophy. Take it up with Paul. Paul will give you a trophy. We have to map these operations to HTTP method types, and this is where we're going to start talking about put and delete. That we're going to add two of these. We talked about get and post already, and we're going to use get to retrieve data, post to create data, put to update data, and delete to, well, delete data. That's our mapping. We talked about get. That's how we're getting data from a user or from a server. Straightforward that should be retrieve, right? Retrieve and list. We'll use it for both. Post is how we're sending data to a server. So it makes sense when we're creating a record, we're going to send the server data, so that should be a post request. The next two, we haven't really talked about this. We're not really prepared to handle those ones, so we need to actually talk about those ones. And the big one is put versus post. So when we're updating a record, what we're doing is sending data to the server. Based on everything I've told you so far, that should be a put request, right? So why are we, or a post request? That should be a post request. So why are we using put instead of post? And the answer is going to be idempotency, which we'll have to talk about quite a bit here. Before we talk about that, I want to talk about what HTTP methods are. Now that you've had your hands on parsing code and you're starting to write your servers and everything, you're more familiar with what these HTTP methods are. So what actually are HTTP methods? What's post, put, get, delete, head? I always blank when I try to list things like this. What are they? They're a sequence of characters in the request line of an HTTP request. And that's pretty much it. Like, there's nothing special about these. They're just a couple of characters. They're 4 characters, capital P-O-S-T or capital P-U-T, and it's the first few characters of the request line. That's it. There's no magic with these things. There's nothing saying a put request has to be this, a get request has to be this. There's nothing saying, nothing enforcing that. That's just it, a few characters. What these methods do and their usefulness is communicating to other human beings what this endpoint is supposed to do. It's given us properties. If I say, hey, you connect to my API, hit this get endpoint, send me a get request for this path, what I'm saying is whatever you send me shouldn't have any body to it. And when you send that to me, I'm going to return some data. I'm going to give you some data. So if I have an endpoint that has those features, I don't expect any data, and I'm going to give you data, I'm going to make that a GET request to make that clear to whoever's reading my documentation and using my API that that's the functionality that request should have. But if I have a GET endpoint that takes a body, that expects a body, expects you to send information with content type, content length, and I don't send you anything, maybe I even delete a record when you do that. Like, nothing's stopping me from doing that except common sense and other developers wanting to attack me. I'll leave it at that. Other developers wanting to take me down. Like, because I shouldn't be doing that. I'm going to make a lot of people mad. But from a technical standpoint, I could do that. Like, it's possible. We can write that code. There's nothing special about your post endpoint when you're taking chat messages. There's nothing special about that. You're just parsing it the same way you do a GET request. You're just expecting something different because it's a post request. So that brings us to put. So GET, I'm communicating that you just get stuff, post, send me stuff. But put, what's put telling me? It's saying you're sending me stuff. A put endpoint is an endpoint where you send information to it. It should have a body to the request, but it should be idempotent is the difference between put and post. Idempotent means that multiple identical requests to that endpoint will have the same effect as a single request on the data of the API. So if I send multiple put requests that are identical, so I say update record 2 to have a chat message of goodbye instead of hello. God, I have the lamest examples whenever I think of something off the top. Then I say put update record 2 to say goodbye, put update record 2 to say goodbye. That's just like if I did it one time. It's just going to say goodbye. Like that's going to be the message no matter how many times I send that update request. Since that's the functionality of my put endpoint, since it is idempotent, I'm going to make it a put endpoint instead of a post endpoint. If I make an endpoint a post, what I'm communicating is that my server is going to do some extra processing after I get that request. So if you send me 2 identical requests to a post endpoint, it will not be the same as if you just sent one of them. But an idempotent endpoint, which put is going to be idempotent, or should be, you should follow this convention. If put is idempotent, you send me 1 or you send me 1,000,000 identical requests, it's the same as if you just sent 1. Get is kind of implicitly idempotent. You're just retrieving data. You can retrieve data 100 times, you just get the same data. Patch, there's options is there was another one I'll add to your list. Options was one I was trying to think of. Patch I always forget completely about. You have a good point. We should. Every lecture and every course should just be, here's the ones and zeros. I don't even want to use hex. Ones and zeros, baby. That's all we're going to code in. Every course, every piece of software. You want to upgrade to a different device with a different processor, with a different instruction set, we're starting from scratch, baby. We're starting all over. Oh, that'd be a tough world to live in. We just wouldn't have software. So get's idempotent. Put and delete are both idempotent as well. So put, you keep changing the same record. Again, identical put requests. Obviously, I can change a record and then change it to something else, then change it to something else. But if I send identical put requests, it's already changed. It doesn't change anymore. So it makes sense for update endpoints to be put and then delete. If you delete a record multiple times, I don't care if you deleted it once or 100 times, it's deleted. What more do you want? You're not going to super delete it or anything, which we can. We went on a tangent in the other lecture. I'll keep it brief in this one because I want to get to the end of this. But with soft deletes, if you send another delete, it's not going to hard delete it after that. Like, we don't do that. We're not going to completely wipe the hard drive because you sent me 100 delete requests. It's idempotent. Doesn't have any extra effect. Post does not. So if you have an endpoint that's not idempotent, we as developers, we've got to think of this the reverse way. If you have an endpoint that's not idempotent, it is a post endpoint, and you should properly document it as a post endpoint, not a put endpoint. If you have an endpoint where you're taking in data from the user and you don't have any extra processing and it is idempotent, make that a put request, make that clearly documented in your API endpoints. Say which ones are put, which ones are post, to let people know which ones are idempotent and which ones are not. Post is not idempotent. In our example, in our homework, if somebody types the exact message, same username, same message in chat, we actually want that to be 2 different records, and that's what our code is going to do. It's going to get the post request, it's going to get that message, it's going to generate a new ID, that's the processing we have to do, add that ID to the record, and then save that to the database. We get another identical post request for another chat message, we generate another new ID, attach that to the new record, and then store that in the database. You send me 100 of those, you're getting 100 messages in chat. It is much different than sending just one single thing. You can spam chat or send a single message. Very different effects. That's a post endpoint. It is not idempotent. So that's the difference between post and put and what idempotency is. Okay, any questions on all this? If you, Zaid, I will read your things. I know this now. I even remembered to, I can't see where he is, but I even remembered to advertise the review session in 116. If you soft delete, how can delete be idempotent if you're not supposed to serve anything deleted to the user? or should delete pretend anything you put in is deleted, even if it's already deleted? The delete endpoint will not return anything, is the way to make it idempotent. So you say, delete this record. You say, yo, okay. Delete this record. Yeah, okay. Like the data that the API serves isn't different anymore because you sent 2 deletes. I'm not going to be 100% on this answer, but I'll speculate a little bit. You can get different response codes. I wouldn't call that serving different data. Like you didn't change the state of the API. So no endpoints change the actual data they're going to serve, even if the endpoint gives you something different. So when you delete for the first time, you might send a 200 level. When you delete for the second time, you probably should send a 404 because you don't want to leak the information that there was a record there or anything. You would send a 404, not an OK. So the response code would change, but I would still call that idempotent. You have to worry about normalization at all when creating databases for this class? I'm going to say no, but I'm trying to remember what normalization even means in this context. My mind went to vectors and making sure all your vectors are unit vectors, and I don't think that's what you mean. But the answer is going to be no if I don't even know what you mean by it. So we're not worrying about normalization, but I got to remember what that means in the context of databases. Normalization is the process of organizing data in a database. It includes creating tables and establishing relationships. Yeah, I'm not going to worry about that. We're only going to have a handful. Even by the end of the semester, we're only going to have a handful of tables. However you organize your data, if you want to put everything in the same MongoDB collection and you have a way of keeping it organized, as long as the endpoints serve what they're supposed to serve, I'm going to be okay with that. And there's never going to be an LO1 where I'm testing your database interactions because that's a pain in the ass to write a grader for, and I don't want to do it, at least not this semester. I'm not going to get there. So however you want to represent your data, as long as it's saved to disk and the database is running in a separate container, I don't care about your organization. I don't care what database you're using. It's whatever you want. Yeah, relationships in Mongo doesn't make a lot of sense either. But assuming you're using, since the normalization definition is talking about tables and relationships, I assume you're meaning SQL. If you're using, I'll take this even further. If you're using MongoDB and everything is in one record of one document of one collection, knock yourself out. I don't recommend that, but I'm not going to stop you either. That would be a pain in the ass, actually. Doing updates, especially. Ooh. All right, so RESTful API. Let's talk about what this is, and I'm going to skim through these slides pretty quick. I did it in the other lecture, too. I don't want to dwell on this too much, but I want you to have this in your vocabulary at the very least. RESTful API, and this is, it's a tough one to define. It's a tough one to talk about. For a while, I didn't even have lecture content on this. Because it's very loosely defined, or at least loosely understood. It's kind of a high-level concept that doesn't have much definition. There is no RFC for it, so there's no actual spec of what a RESTful API is. And I got to get the guy's name in my slides. I usually don't do names, but it's actually just one dude's PhD thesis. They said, this is what RESTful API, I'm inventing this thing, and if you have an API that meets all these criteria, you can call it RESTful. And that's all we have to go off of. Like, that's it. That's what it is. No review process and no community iterating on it and really defining what it is. But this is a term that's really taken off. It's out there everywhere in industry. And I'll be honest, I have a tough time pinning it down exactly what RESTful APIs are. I've worked on this for a while. I finally kind of get it. Because I can't come up with examples, I struggle at least, to come up with examples of APIs that are not RESTful. RESTful just seems so intuitive that, like, why would you build anything else? Everything we're talking about with CRUD and these mapping the GET method, the HTTP methods, all of that stuff, that's a RESTful API. If you just take away what we talked about in class, that's a RESTful API. But whenever I ask someone, like, can you give me an example of a non-RESTful API? And they give me an example, and I'm like, that's just dumb. Why would you do that? So maybe it's a me problem where I'm just like, RESTful is the natural thing to do, that it's hard to define it because I don't have anything to compare it against, because everything to compare it against is just the dumb way of doing things. So a RESTful API, but nevertheless, let's get into it. This is used as a verb more often than not. I usually hear it used as, developer A is like, hey, let's build this feature like this. Let's design it this way. And developer B goes, yeah, but that's not very RESTful. Then you go, oh, yeah, okay. That wouldn't be very RESTful, so let's not do that. Or let's try to make this API a little bit more RESTful. The example of multiple things happening, if you hit one endpoint, one HTTP endpoint, and multiple things are happening in the database, that's something that I would call not very RESTful. And I would also call it a bad idea. It's not a good idea. Sometimes you have to design endpoints like that, but it's not a good idea to do that too much. So RESTful has certain constraints. That PhD thesis, it laid out here, you have this, 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 this. If you have all these, you're RESTful. If you're missing some, you're not as RESTful. One is client-server architecture and statelessness. Well, we're using HTTP, so that's a big old check mark right there. We're done. The RESTful APIs do not have to be web APIs. It's just a more general thing than that. Okay, and if you have any authentication on your RESTful API, it's technically not RESTful. If you really get nitty and gritty with the detail, the definition of this, having an auth token for your API and not having just open to the whole world, it violates RESTful statelessness. Like it violates that. But nobody cares. You're not going to do that with your API, and you're just going to be okay with it. It needs to have some cacheability. It needs to be a layered system, meaning you can add additional layers in between your server and the user. And this is something we will do by the end of the semester. We're going to add a reverse proxy in between our user and our server. And that's perfectly fine. We're using HTTP requests. Whatever the user sends, as long as we get that HTTP request eventually, it doesn't matter how many layers there are in between. But we can't have to have like a stateful connection between two users to use a RESTful API. It's not RESTful anymore after that. And it needs to be self-contained. Everything about the thing needs to be in the database itself, or the API itself. This is why when we get to AO1, you have to update your GET request to return the record that was created with the ID. That's to make it RESTful.